Types of reagents. The reagents can be classified as nucleophile, electrophile and the carbene. Nucleophile, as the name indicates, nucleus loving. That is say the one which is electron rich and attacks at electron deficient points. If nucleophile has two different points of attack, that is say at two different atoms the lone pair of electron is present, then it is called ambient nucleophile. For example, cyanide, thiocyanate, nitro. These are ambient nucleophiles. Nucleophile donates its lone pair of electron to the substrate. Electrophile is electron rich, electron loving species and is itself electron deficient. Electrophile is a Lewis acid, whereas nucleophile is a Lewis base. Most of the metal ions, transition metal ions, are electrophiles. All the ligands are nucleophiles. Then the third one is the carbene. Carbene is divalent carbon with two electrons. If both the electrons are present in the same orbital, it is called singlet carbene. If both the electrons are in different orbitals, it is called triplet carbene. Singlet carbene has got a vacant p orbital, so it requires a lone pair of electron. So it is electron deficient. Hence, it acts as a electrophile, rarely behaves as a nucleophile. It is diamagnetic. Carbon is sp2 hybridized. In triplet carbene, the unpaired electrons are in different p orbitals. So carbon is sp hybridized. Shape is linear. It is a diradical and it is paramagnetic. Now, as we move down the group, nucleophilicity increases. Nucleophile and base. Basically, the main difference is nucleophile attacks the carbon, base attacks a proton. Nucleophilicity decreases along the period but increases down the group. Now question is, nucleophilicity of NH2 minus, CH3 minus, OH minus and F minus is in the order. Just now I have told you that as you move along the period, nucleophilicity decreases. So first of all comes the carbon, then nitrogen, then oxygen, then fluoride. Hence the nucleophilicity will be in the order second is greater than first, is greater than third, is greater than fourth. So the answer is 3. In the same way he can ask you, out of H2S and H2O, which is a better nucleophile? As you move down the group, nucleophilicity increases. So H2S is better than H2O. He may ask you, out of ammonia and phosphine, which is a better nucleophile? Phosphine is a better nucleophile as compared to ammonia, because as you move down the group, nucleophilicity increases. If a nucleophilic center has two or more species, then nucleophilicity parallels basicity. So nucleophilicity of RCO minus, RO minus, OH minus is in the order. In all the three cases, the nucleophilic site is oxygen. Nucleophilic site is oxygen. And we have just now seen, if the nucleophilic site is same, then nucleophilicity parallel basicity. So what you do? Add hydrogen, form corresponding acid. Stronger the acid, weaker the base. So first will give you carboxylic acid, other will give you alcohol, the third one will give you water. Alcohol are less basic than, alcohol are less acidic than water. So RO minus is a stronger nucleophile than OH minus. Carboxylic acid is the strongest acid, so carboxylate ion will be the weakest carboxylate ion will be the weakest base, hence strongest weakest nucleophile. So the answer will be second is greater than third is greater than first. Second is greater than third is greater than first. Second, I have told you, if the nucleophilic center in two or more species is same, then nucleophilicity parallels basicity, means stronger the base, stronger the nucleophile. Now in order to see the stronger base, you form the corresponding acid. Add H plus to all the three. First will give you carboxylic acid, other will give you alcohol, the third one give you water. We know alcohols are weaker acid as compared to water. It means RO minus is the strongest nucleophile. So second will be strongest. Then comes OH minus, then comes first. Hence the answer will be second is greater than third is greater than first. If the atom bonding to the nucleophilic center also has a lone pair of electron, nucleophilicity increases. So HO minus will be a stronger nucleophile as compared to OH minus. Now the question is, nucleophilicity of hydrazine, ammonia and amide is in the order. Out of ammonia and hydrazine is stronger because nitrogen adjacent to nitrogen also has a lone pair of electron. Now amide is the weakest because the carbonyl group is electron withdrawing. It will withdraw the electrons of nitrogen. Resonance can also set up. Hence the answer is first is greater than second is greater than third. For the same nucleophilic center, basicity increases but nucleophilicity decreases due to steric hindrance. Once again, nucleophilic center is same, means in all the three oxygen is the nucleophilic center. Then basicity increases but nucleophilicity decreases.